Hello, everyone. Good evening, good afternoon, or good morning from wherever you're joining us from today, and welcome to a Microsoft Reactor live stream event for Supercharge your Azure connectivity. My name is Nadia, and I'm the Reactor Program Manager here in Sydney. And today I'll be joined by Deepak, who is a Principal Customer Engineer at Microsoft, and Romel, who is a Senior Solution Specialist for Azure Core Advanced Networking at Microsoft. But before we kick off this session, I'd like to draw your attention to the Reactor Code of Conduct. In short, we want to ensure that this is an enjoyable event for all, so please ensure your comments are constructive and welcoming to all attendees. Please do send us your questions throughout the session in the chat, and we'll try to answer as soon as possible. Additional links will be added to the chat throughout, including our survey. If you have time to fill this out, that would be greatly appreciated. It helps us give us the content that you're after. If you would like to reference back to today's session, you can do so on our Reactor YouTube channel. Now it's time for me to hand the floor over to our incredible speakers. Thank you for joining, and over to you, Deepak.
Cool. Thanks, Nadia. Hi, everyone. Let's talk about Supercharge your Azure connectivity with Virtual WAN. Virtual WAN is a Microsoft managed networking solution that provides end-to-end network connectivity in Azure landing zone. And in this session, both Nirmal and I will talk about how you can supercharge your Azure connectivity with Virtual WAN. So let's have a quick overview of Virtual WAN and what the Virtual WAN is. So as we talked about, Virtual WAN is a managed network service. So it's a Microsoft managed network service, which allows you to connect all of your branch offices as well as the Azure virtual networks all together. So the way it works is you basically create a virtual WAN. So you deploy a virtual WAN, and as part of virtual WAN, you can deploy virtual hubs. So hubs kind of represent your region. So if you've got multiple regions, you will be deploying multiple virtual hubs to represent each region. If required, you can deploy one or more hubs in the same region as well. You can then connect these hubs with variety of different services, things like point-to-site VPN, site-to-site VPN, express route, as well as SD-WAN appliances. So you have got variety of options, and it allows you to connect multiple services to virtual WAN. If required, you can also make these virtual WAN secure. So these hubs can be made secure by deploying Microsoft Azure Firewall or any third-party network virtual appliance. So you bring that firewall and make it secure, and all the communication which goes back and forth between branch and your virtual network, that can be secured using the firewalls. You can then further connect these virtual hubs with the respective virtual networks available in those branches. And what it gives you essentially is it gives you basically any-to-any connectivity architecture. Instead of having multiple route tables, your users who are connected from point to site can connect to the branch, which are available in totally different region. And it all can connect securely. And with Virtual WAN, it provides you the automated mesh topology, which means everything is kind of meshed. And if you want to restrict any communications, you can also create firewall rules to allow or disallow that communication. Now, Virtual WAN supports the advanced routing capabilities, things like routing intent, which I'm going to talk about in a moment. It also supports the BGP peer as well as route maps. We also got a partner ecosystem. So partner ecosystem has been around for a long time. So there are like IPsec CP connectivity providers, which allowed SD-WAN solutions to connect to the Azure Virtual WAN. We then introduced different SaaS security solutions, things like Checkpoint, iBoss, and Zscaler. We also introduced managed NVA within the Virtual WAN. So you can use Microsoft Virtual WAN, or if you are using SD-WAN from a different partner solution, you can also use it along or inside the Virtual WAN. And this partner ecosystem is enhancing or updating frequently. We now support Fortinet, Checkpoint, Aruba, Palo Alto and other firewalls. And there are more coming soon. Now, talking about the partner ecosystem, now, what were the biggest challenges which customer had? The biggest challenges were customer had to manage their UDRs, customer had to manage the appliances which they have deployed in this environment. And it was more like do it yourself and kind of fragile scenario. And on top of it, it was difficult to get the support from Microsoft because you have to reach out to Microsoft for network services, as well as you need to reach out to the NVA vendor for that network virtual appliance support. Now you have Azure Virtual WAN integrated NVA, which are simplified deployment. So you can use the choice of your tools like Terraform, Bicep, or ARM template. You deploy these services, it gets deployed in Azure. It's highly available, and it's a streamlined joint support from Microsoft and the NVA vendor provider. So the workflow works in a way that you select the choice of your NVA, you make the deployment, and the service gets deployed within the virtual WAN, and it makes the IBGP connectivity to the branch side and EBGP connectivity to the virtual networks to inject the routes in the network. Now let's talk about the new enhancements, which is the hub routing intent and routing policies. Now the hub routing intent, it's a new enhancements which have been recently, became GA. And what this provides is, it provides you the inter-hub, inter-region connectivity. So virtual WAN always had an option of connecting multiple hubs together. So when I say hub, means you have multiple regions, and you could connect those multiple regions together. But there was a gap when it came to connecting those hubs or branches when you're using the secure firewall. Now, it is fully supported with the routing intent. So you can have Azure Firewall deployed in each branch or each hub. And now your traffic can route through those firewall, and you can allow or disallow the traffic you want to route through. Now with this, I will just quickly jump onto my demo environment, and I'll show you a quick overview of virtual WAN, its configuration, and how do we configure routing intent, and how do we verify how the routing intents are working. Now to simulate this environment, I have got 3 virtual hubs. So I deployed my virtual WAN, and this virtual WAN is deployed in Australia East. So I've got 2 virtual WANs deployed in Australia East, and I've got 1 in Australia Southeast. So if required, I can have multiple virtual hubs, which can be deployed in multiple regions. My first hub is actually connected using the express route, and it's connected to my on-site VM, which is in a different IP address range. So you could see in this example, I'm using 172.16 series for one of the hub, 17 series for another hub, and 18 series to my third hub. Now, what I'm going to do in this demonstration, I will show you the connectivity from one hub to another. And to make it this demo interesting, what I've also done is I have deployed 2 different VNets in my hub, which is also in Australia East. So I've got 2 hubs in Australia East. One of the hub is representing my non-production environment, and another hub is representing my production environment. And what I have done in this demo, all the traffic in this hub is secured by firewall, and all the traffic in this hub is only secured by the firewall when it is the internet bound traffic. All the intranet traffic or the private traffic, that is not secured by the firewall. So I just wanted to show that it's not one or the other. It is basically different options we can choose from when it comes to configuring routing intent. So I will first go and look at my virtual WAN. So I've got 3 hubs. As I talked about, these are my hubs which are deployed in my environment. and these hubs have been deployed in different regions. So you could see 2 hubs in Australia East, 1 hub is in Australia Southeast, and my first hub has got my express route circuit configured. And if I look at the configuration of my hub, I have got hub to hub network connectivity enabled, and I've also enabled branch to branch connectivity. So this is how it's configured. If I go back to my hub, so this is something which is representing a region. So as I talked about, I can have hundreds of hubs deployed, and each hub can support up to 500 virtual network. And the way I have done is, I will show you my virtual network connection. If I select my virtual network connection, it will show me how many VNets are connected to each hub. So we are representing each hub in the region plus the virtual networks connected with that hub. So you could see you've got 2 virtual networks in my hub 2, which is in Australia East, and I've got 1 virtual network in each hub I have in my environment. And what it basically does, it just creates any-to-any connectivity. So all these connections I'll make to my hub, they will allow all the communications to flow through using these hubs. Now, in order to verify this, I can simply go back to hub, maybe select hub 1. And if I look at my effective route, this will show me the effective route of this hub in terms of what route this hub is getting from another hub. So since this hub 1 has got the firewall enabled for both private and internet traffic, I will look at the resource type as Azure Firewall, and then it's gonna show me the effective routes. So I can have a look at this one, and what it shows me is I have got the express route connectivity, which is my 10.150 series IP address, and I also have got the virtual network connection. So this is the VNet connected to the hub, which I'm checking right now, and these are my remote hub. So I've got 1.0 and 2.0 part of my hub 2, and I've got 18.1.0, that's part of my remote hub. So I can verify, yes, all this traffic will go via the hub. So it means I have got hub to hub communications enabled. Now, if I look at my express route, so if I change this, I've got my express route connected. And if I look at my other hubs, it will also show that the way to connect to this express route is using the hub 1. So if I just change this and go and maybe select hub 3, and if I look at the effective route of my hub 3 as well, and I'll use Azure Firewall, and I will select Azure Firewall hub 3, and then this will show me what are the effective routes for this hub. So this shows my express route is connected using hub 1 AUE. So that's the hub I will need to use in order to connect to my express route. Because in this, so if I take the example here, this is my hub 1, which is connected to the express route. This is my hub 3, which doesn't have a direct connectivity to the express route. So it has the information to go via hub 1. So that's what my effective route is displaying. And the same thing, if I need to see, I can even go back and check it my hub 2 as well. So there is an interesting configuration I have done on hub 2. So as I talked about, my hub 2 doesn't have the security configured using Azure Firewall for my private traffic. So I'll have to use and look at my route table in this case, and I'll look at my default route table, and this will show me the connectivity. it shows me the same configurations. In order to go to my firewall, I will be using hub 1. And it also shows that other hubs are directly connected, and any VMs which are part of this hub should be able to communicate to the VMs which are part of other hub, as well as the traffic which is actually originating from or to my express route circuit, which is my on-premises network. Now, so as we have seen, we can create hubs. They're going to represent my region, and every hub is connected to the virtual network connections, which basically, allows any-to-any communications between the virtual network. Now, what I want to show is the new feature, which is the routing intent. So let me just quickly go back and show it into the hub configuration. So there are two ways we can configure the routing intent. One is using the firewall manager. So if you are using Azure Firewall, you can also use Firewall Manager to configure the routing intent. Or if required, you can configure the routing intent in each hub as well. So let me quickly show you that. So if I go on my hub, and if I look at my hub 1, and if I look at my routing intent and routing policies, so this is a new feature, which is basically gonna give me any-to-any connectivity. So we can see all of my internet traffic is going via the Azure Firewall. And all of my private traffic is also going via the Azure Firewall. Now, as I talked about, this is configurable. So if I look at hub 2, I have a different configuration. So I have represented my hub 2 as my dev and test environment, and maybe I don't want each and every traffic routed via the firewall. I just want all the traffic is routed through the hub or hub's router, but should not go via the firewall, because I don't want to manage a lot of rules on my dev and test hub. So I have excluded the private traffic and I've selected as none, but if required, it is as easy as just selecting the Azure Firewall. By selecting this option, I'm not, making any impact on my routing. I still have got the routing. I can still, ping the IP addresses. The only thing what's going to happen is now any traffic which originates and which is the private traffic will not go via the firewall deployed in this hub. But yes, if the traffic reaches to the other hub, that traffic will be actually inspected in that hub. So yes, if you have got this mixed environment, one of the hub will inspect the traffic where the firewall is configured. And the hub which doesn't have a firewall will not inspect the traffic, which is the private traffic. Now, another option to configure this is using the firewall manager. So as I talked about, we can do it either using the firewall manager or using the hub configuration under the vWAN. So the way we do is we select our firewall manager, we select the hub, and then look at the security configuration. So when I look at the security configuration, it shows my internet traffic going via the firewall, my private traffic is also going via the firewall, and my inter-hub communication is enabled. And if I go back and look at my another hub, maybe I'll see the hub 2 in this case. And if I look at the security configuration, I have got internet traffic going via the Azure Firewall, or the private traffic is bypassed, via the Azure Firewall. And I can also see it here that all the internet traffic is, going via the firewall, and all the private traffic is actually unsecured. Now, in order to see how it works, what I've done is I have actually created multiple VMs in each hub. So I've got 4 VMs, and just to come back to the DAM environment. So I've got 1 VM in each hub, and I've got 2 VMs in this hub. So now what will happen? I will try to ping VMs from one hub to another. And what it will do, it will basically log its traffic in the log analytics. So the traffic originating from this hub, since it's not using the firewall for routing, will not be logged here. But traffic originating from these two hubs will actually log its traffic in the firewall. So if I'm communicating from here to here, the traffic is basically going via this firewall and should be logged at each firewall. Any traffic which is going to my on-premises will also go via the firewall, because that is also a private traffic. And as per our configuration, that's what we have declared, that all the private traffic should go via the firewall. And for this hub and this hub, all the traffic will go via the firewall. Now, in order to do that, what I'll do, I will just connect my VM. So I've got VMs deployed in each hub, as I talked about. So this is my Australia East hub, and this is my Australia Southeast hub. This is my Australia East second hub. So I've got VMs in each hub. So what I'll do is I will actually ping these VMs. So I'm going to ping the VM, which is in Australia Southeast, which will generate the ICMP traffic. And I've got the communications allowed in my firewall. And if I try to ping my on-premises, all of my traffic is allowed because this is branch any-to-any configuration. Now, from my Australia Southeast branch, I'm also trying to connect to my another hubs. So I'm just generating this traffic. I will also generate the traffic to my first hub, which is in Australia East. That's all going through. And for this hub, I will ping to my hub in Australia Southeast, and I will ping to my hub in Australia East as well. And I'll also ping to the traffic. I will also ping the VM, which is deployed in on-prem. So this should actually generate the ICMP traffic. And if I actually go back and look at my log analytics workspace. So if I go here and look at my log analytics workspace, so I have this query, what it's doing, it's looking at all the ICMP traffic. So what I've done is I've configured these firewalls to log all its traffic or all its log to the log analytics workspace. So I've combined all the three firewalls into a single log analytics workspace. And I'm going to run this query and verify is this communication is hitting the firewall. So you could see I've got firewall 1, which is actually hitting the traffic. I've got firewall 3, which is hitting the traffic, but I do not have anything for firewall policy 2. So there is a firewall in hub 2 as well, but since we have configured all the private traffic should not go via the firewall, that's why there is no firewall rule is getting hit, and that's why the policy doesn't have that firewall rule. So even if we refresh, because when you start pinging, it takes a little bit of time to start showing up in the logs, and I could see the policies which are getting hits are policy 1 and policy 3. So I represented my policy 1, policy 2, policy 3 in accordance to my hubs. So hub 1 has got policy 1, hub 2 has got policy 2, hub 3 has got policy 3. So we can see here that the traffic which is originating from different source and different destination IP, they're not hitting the firewall policy 2 because we have configured our routing intent not to go via the firewall when it comes to the private traffic. Right, so that pretty much concludes my demo. And I will now hand it over to Nirmal to talk about route map and IPsec security for the express route. Over to you, Nirmal.
I shall bring up my slide. So, as Deepak mentioned, what we will do today is cover few scenarios specific to virtual WAN, and also to talk about how do we extend some of the new enhancements that's released with routing intent. So what I will do is I will walk through a few scenarios. First one is to talk about express route with VPN encryption, which is a very common scenario we see with customers who are having compliance requirements needing to encrypt the express route path back to on premises. And then I will also cover some of the newer changes that's introduced with point to site VPN. And then finally, we'll also look at additional preview features that's available within virtual WAN. So to get started with the express route scenario, I'm going to switch to my whiteboard. So I want to run through this scenario just to explain what I have set up in the environment. So as I mentioned, there are a lot of customers who are looking to encrypt the express route path for different regulatory requirements. And initially, when routing intent was generally available, there was no support for express route encryption. And the reason for this is the traffic path goes via the firewall. So we need to make specific rules in the firewall to allow this traffic to flow back to on premises. Without that, the solution would not work, and you would end up the VPN not being able to establish the tunnel back to the endpoint on premises. So in this environment, what I have done is I have created an express route circuit utilizing one of our express route partners. So that is this circuit in here. And then I have built virtual WAN hub. I've enabled secured hub. So the firewall is deployed within the virtual WAN hub. I've also turned on routing intent. And then what I have here is I have two different spokes that are connected. And then what I have also built is two gateways. So one for the express route connectivity, and I've also built a VPN gateway as well, which is going to be my overlay connectivity, utilizing the express route as an underlay path. I've also built my on-premises simulated environment. This is also on Azure, but they're all connected through an express route circuit. This is built with a VNet. There's also a gateway in here. And then I have a OpenSense a VM, which is going to be the one that is going to establish the VPN tunnels to my virtual WAN hub. And then I also have another VNet that is attached to this on-premises simulated VNet. And in this particular VM, I have installed a sample web app. So we can run a few curl queries and then look at the firewall log to understand how TCP and UDP traffic would pass through the VPN tunnel that we built towards the virtual machine that I have in my spoke VNet behind this on-premises hub. So that is the setup that I have built. I'll also explain the way how the traffic path would work. So as you can see in the diagram that I have here, there are three different traffic flows that takes place. So the first traffic flow is the VPN establishing the IPsec connectivity between the appliance that I have, the NVA appliance that I have in my simulated on-premises hub with the virtual WAN VPN gateway. So that is this path here. So that is the path that will go. This is the path. So this path here. So this is the path where we have inbound connection coming from the on-premises device, and that traffic will go to the express route gateway, and from the gateway goes direct to the VPN gateway. And then what happens is the traffic, once the tunnel is established, we would have traffic that will go to the VMs. So if I'm sending traffic from this endpoint that is in my branch, or if I'm sending traffic from this endpoint here, that traffic will hit the firewall. So traffic coming from the spoke hits the firewall first. So that is the green path. And then from here, because if you look at how routing intent work, and as Deepak explained before, all of the traffic in your secured hubs, if you set private traffic inspection, all of the traffic would land on the firewall as the next hop. So all of the private prefixes are pointing towards the firewall. So for me to connect to this VM here, I'm having traffic sent to the firewall, and the firewall will be sending that traffic to the VPN gateway, because we are learning these branch prefixes only through the VPN gateway. And then what happens is the return path from the gateway will go to the firewall, and from the firewall it will be going back to the express route gateway, and from the express route gateway it will come back to the VPN device, and from here it will get forwarded back to the web service or the VM that I've hosted in this simulated branch spoke VNet. So that is the outbound path, which is explained by this particular dotted lines. This is explaining the outbound path, how the outbound only hits the firewall, whereas if you look at the inbound path, it does not hit the firewall. So it's important for us to make sure there is a firewall entry allowing traffic with the source from this VPN gateway IP, and then traffic going to this destination. So we will be able to verify all of this when we view our Azure Firewall logs. That will show us what are the additional traffic outside of the TCP web request that I'm sending to this destination. You will see in the log there is other traffic flows that will happen, which is the ESP UDP packets that are sent via the VPN gateway to this VPN device on the other side. So that's a quick explanation of what I have in the lab. What I will do next is I will go to the Azure portal and walk you through how I've set this up, and also do a quick demonstration to show how this works, and also we'll have a look at the firewall logs to validate the packet flow that happens when the VMs talk from this end to the VM on the branch side. So moving to my Azure portal, I'll start with my Virtual WAN hub. So in this Virtual WAN hub, you will see that I have the firewall deployed. And in here, when I go to the hub, we will see that it is having an express route circuit connected. So this will list different circuits that I have. But this one in specific, you will see that it is connected to this hub locally. So that is our underlay path. We have express route connected to this hub. And then what I also have on top of that is I have this VPN site that I've created. So this is the site configuration that is then talking to the virtual machine that I have configured in my branch spoke. So if I scroll down, you will see here I have this site branch. And if I move to this side, you will see I have the option to view this configuration. So here, if I go edit connection, this would then show me the different type of configuration I have for this particular branch. And you can see that this is utilizing a BGP for route propagation. So routes are dynamically advertised from the branch. So now if I go to this branch configuration, you can now see here, this is the links that I have configured. But the important thing here is the IP address that I'm talking to. So you can see that this is not a public IP. So I'm not sending traffic out to the internet. Instead, what I'm doing is I'm using the express route as my transport to send this traffic from the vWAN hub all the way back to my on-premises VNet, effectively applying encryption in that path for traffic that is going back to my on-premises VNet. So that is the setup. And if I go in here, you will see in the BGP dashboard, it will show me what are the routes that are being learned by this hub. Also, it will show me the connectivity status, just giving assurance that the BGP sessions are up and running. So you can see here, I have these two gateway instances, and you will see here the ASN that I've attached, and we can see here that these are all connected and working as expected. If we do go to the learned route section, here you will see the 10.3 prefix, which is the one that is coming from the branch, and that is only advertised by the VPN device. That prefix is not advertised via express route. So you can see here, this is the prefix that I was mentioning, and you can see what is that origin of that particular route. So that is only advertised by the VPN device on premises, and then injected to my virtual WAN routing table on the hosted on my Azure environment. So with that, that is confirming that this is setup is connected. So we have the express routes up and running. We have the VPN tunnels connected. Next thing what I will do is I will quickly switch to one of the VMs that I have. So I'll just go into VM1. So this is the VM that is hosted on my Azure environment. And then I'm going to be connecting from this VM to my simulated branch environment. So for this, I'm just going to connect through the serial console and just going to run a few curl commands. So once I run some of these commands, what you will see is you will see that I'm able to then go and view all of this configuration within the Azure Firewall. You can also then go analyze the traffic paths that we have. So I'm just going to run a few tests here, and you can see the response is a 200. So I'm getting a response back from the branch. And also if I do trace path in here, if I do a trace path against the IP address, you will see that this is hitting my local firewall. So these are the two IPs that is used by my local firewall. So it's hitting my Azure Firewall in the local hub. And from there, it is getting sent to the branch that I have created in my other VNet. So that's the traffic path. And we are validating that the traffic is flowing without any disruption. So the next thing to have a look is, now that we know there's traffic going on, we can also look at identifying, how is this VNet able to reach the branch that I have created. So to do that, I'm going to go to my firewall instance. And in the firewall instance, I'm going to use logs. So this is, again, sending all the logs to my log analytics repository. And here I'm just going to say, show me all logs. And the intention here is that we are expecting to see two types of traffic. One is the TCP traffic, as I mentioned, because I'm using curl, and then I'm hitting the web app that I'm running on that particular VM. So this is using port 8, that the source IP on my spoke one VNet, and then we can also see the target IP in here. So that is the TCP traffic that's flowing through. And then what you will also notice is there is another traffic flow that happens, which is essentially using 4500 port and also port 500. But these are all UDP traffic. And you can see that this is originated from my VPN gateway in the hub. So that is the 168.1.5 address. And then this is being sent to the VPN appliance that I have in my simulated branch environment. So that's the 10.100.0.4. So when you configure this sort of setup, if you want to encrypt your express route with a VPN connection, you need to make sure that you are allowing this traffic flow to run through. Without this, the solution would not work. We have recently updated the documentation to reflect this. So this is a configuration that is required for this configuration to work. So you can see here 4500, which is essentially the ESP traffic flow that is going from the VPN gateway on the vWAN hub going to the on-premises appliance that I have created, or the simulated branch. The other traffic flow is on port 500. So that's I traffic that is going back to, again, to the same location. And that is also having the same address. You can see here, I have some flows that are using 4500, and there's some flows that are using port 500. And these are all UDP traffic. That is why even if the traffic flow is not symmetric, traffic can still pass via the firewall because this is UDP traffic that's going in. So that is how you get encryption to work together with routing intent. There are two considerations. The first thing to keep in mind is if the firewall that you're using is a premium firewall, and if you have turned on IDPS or intrusion detection and prevention. So if you have an IDPS policy applied, you want to make sure that inside the IDPS configuration, you want to bypass these IPs, because you don't want your bandwidth to be capped by the capacity of the firewall, specifically for any IDPS inspection. So that is something for you to consider if you're especially looking to roll this out at scale. These are some of the things to consider from a firewall point of view. Outside of this, other things apply. You have to keep in mind on the limits that are available based on the encryption algorithm that is applied on your VPN tunnels. If you use GCMA ES256, you will be able to reach around 2 Gbps per tunnel. So more bandwidth you need, you will have to establish multiple tunnels if you want to reach a higher capacity. So that is a very quick demonstration. Again, if I go back to my whiteboard, a very quick demonstration to show how we can utilize ExpressRoute encryption together with routing intent. And this is how you set it. These are the firewall rules that's needed and the ports that you need to enable for this traffic flow to work and enable encryption all the way from the hub to the destination appliance that I have created in my simulated VNet. The other capability I'm going to touch on is something that is new that was released in GA a couple of weeks back. This is a capability where we are using point-to-site connectivity. So Deepak mentioned at the start, we have multiple methods of connectivity to Virtual WAN hub. So in Virtual WAN, you can mix and match different type of connectivity. So here, if I go back to one of my environments, so this particular hub that I have created, in this hub, when I go in, I can create a different type of connectivity options. So I have VPN, I have ExpressRoutes, I have use a VPN point to site. So one of the new capabilities that's added with point to site is the ability to create multiple groups inside the same hub. So why is this important? Typically, in a customer scenario where you have multiple departments or multiple business units, you want to maybe provide a different set of IPs to each of the individual groups, because you want to specifically identify based on the client IP that's allocated. The reasoning behind this is you might want to apply different firewall policies. So example, if you are coming from the HR organization, you're coming from the IT organization, you might want to apply a different set of firewall policies. So you want to specifically be able to identify based on the IP which group you are part of, or how you want to apply policies. So before the multi-group capability that was announced, all of the users, regardless of which group they are part of or where they belong, when they connect to a vWAN hub from a point-to-site context, they always get one IP from a large pool of IPs. So we didn't have a capability to specifically identify user based on a group and specifically provide different IPs. The workaround back at the time was to create different hubs, which means that you will have a dedicated hub for, let's say, the IT users who are coming in, and you would have a dedicated hub for HR users who would be connecting. So with this feature, we don't need to have multiple hubs. Instead, we can have one hub. And in the hub, we can then go in and create multiple groups. And these groups can then be mapped to different IP prefixes. And then you can say you are part of the HR group. So you can use Active Directory groups, or we can use on-premises Active Directory as well. And then based on that, we can create the allocation of the IP addresses. So the way how this works is in the point-to-site configuration, you can go in and select the option to now add the user groups. And then in here, you can construct how the groups should be created, how many groups should be there. And you can also provide if you have existing groups. So here you can see I have created one profile, but in here I have 2 teams that I have added. And if I edit config, you will see here I have the option to go and create this new tab with user groups. And here I can go create multiple groups. And for each group, I can now say how this group should be mapped based on a radius attribute. If I'm using my radius authentication server to authenticate against on-premises, or if I'm using Azure Active Directory, I can also say this is my Azure AD group ID, use this group ID to then match these users. So you have a lot of flexibility in how you can do it. You can have a priority. You can also select a default group as well. So if there's no match, you can say, go ahead and provide an IP for these users who are not specifically matched to these groups that I have already configured. Once you have configured this, you can then go to your specific point-to-site gateway. And in the P2S gateway, you can then specifically allocate the different IP addresses. The other capability that is also released is also around the way how we can mix and match authentication. So in the past, we had to select a specific authentication type when we go and create the profile. But now you can mix and match. So example here, I have selected OpenVPN as the way how I authenticate my users. And I have also at the same time selected IKV2 as a way to authenticate. So this is again a great use case for customers who are either, let's say, migrating from direct access and they want to leverage some of their own premises infrastructure that they've built. They might be having radius infrastructure that's already built. But at the same time, you may be having certain users that are migrated to the cloud or already utilizing Azure Active Directory groups. And you can then use the, you can mix and match. So you can have set of users while using the OpenVPN client and then using the Azure VPN client to connect back. At the same time, you can also have Windows 10, Windows 11 always on client to also connect to the same gateway. So you got a lot of flexibility as to which authentication providers you want to use. And also with the new P2S groups, we can now also offer a lot of flexibility as to how you can mix and match different groups, but they will live inside the same P2S gateway. So the last thing I want to show here is if I go to my P2S gateway, and in here, if I click on the address pool, you will then get the option to match different address pools per group that you had created in the previous view. So here you can see I have team 1, I have team 2, and here I have the option to then provide the different client addresses. So here I have 10, 80, and 10. And then if I go to my group 2, in the group 2, I have given a different client address prefix. So now I can mix and match all these different teams, but they are all connecting to the same VPN gateway, same P2S gateway. So that is all I wanted to cover in the P2S side of things. What I will do now is I want to talk about some of our preview capabilities that's added recently to Virtual WAN. So with this capability that we've added, we are going to provide the ability for customers to manipulate routing when routes are advertised back to on-premises or routes between different VNets. So per connection, we will offer the ability to control routes based on either the route prefix. We can also give you the ability to look at things like the ACE path and go change the ACE path. Or we will also give you the ability to apply a BGP community string as well. So these are the 3 options that's available. And based on the different connections you have, whether it's an express route connection or a VNet connection or a VPN connection or even a P2S connection, based on this, we can then start applying route manipulation. So why is this needed? The use case here is also customers who want to reduce the number of routes that are advertised either from Azure to on-premises, or for customers who want to summarize some of the routes that are advertised from on-premises to the cloud. You can utilize routes map capability to create a route summary and then advertise those routes to your environment. So with that, what I will do is I will go to a very quick demonstration. So in this demonstration, I will I'll do a live demo and show how this feature works in the environment. So for that, I'm just going to go to my second whiteboard here. So I'll quickly explain the lab scenario here. So here I have created a virtual WAN hub. Again, I'm using an express route circuit that is connected to one of our express route partners. And then I have created multiple spoke VNets. I, in fact, have 5 different spoke VNets. So as you know how this feature works, so example, if I have 5 VNets connected to vWAN hub, and then on top of that, if there is a express route circuit that is connected, what happens is all of the routes will automatically get advertised back to the express route circuit. So before I do anything with route maps, I'll just go and show you the default behavior, how express route works with vWAN. So for that, I'm just going to navigate to my Megaport setup. So this is again one of our express route partners. So you can see in here the VNets that I mentioned. These are all propagated from my express route environment to my express route partner. So if I am not using the partner capabilities to view these routes, if I had a device on premises, we will be receiving all of these prefix to my on-premises router. So that's the default behavior. Whenever a VNet is attached, the VNet will use gateway as the route propagation. So we use gateway on the vWAN hub, and that will then send the prefix back to on-premises. So now what we do with route maps is we will give customers the ability to manipulate this environment. So I can now go and change the way how routes are advertised back to on-premises, and I can do this by connection. So in order to do this, because when we do apply the config, it will take a couple of minutes. So what I will do is I'll first go and apply this change. And then once the change is applied, while it's in progress, I'll explain the way how the route maps are created. And I'll walk you through the different options that we have and how we can go manipulate these different configurations. So the first thing I want to do is, you can see there is a map here, but this is not applied to any connection. So I'll quickly go and apply it now. So I'm just going to go apply connection. And here, I'm just going to say I want to do an outbound map, and I will select the express route connection. I'm just going to hit save. So I'll let this operation complete. But what I will do is I'll go back to my virtual WAN hub and walk you through the different options that are available inside a route map. So in order to do this, I'm going to say I will create a new route map. So you can see here I have this option to go create a new map. So I'm just going to say this is my custom map 1. And then I have the option to go and add the different rules that I'm going to do. So here I can say this is route rule 1. And then very similar to how we process our Outlook rules, you can then say, do you want to then continue processing other rules that you have in your environment, or whether you want to terminate from here. So if this is a process, then there will not be any further processing of rules that will take place part of this specific map. So once you set these properties, you can then select the way how you want to apply this policy. So here, one thing to keep in mind is if you don't do any kind of match, then it will get applied to every single route that is propagated from that particular connection. So here, if I want to do a specific match, I will select how I want to match the conditions. So I can match it by the route prefix. So here I'm going to say route prefix equals, and I can provide a specific address, or I can say route prefix contains, and I can provide like a summary address. So example, if I switch back to my whiteboard, you can see here I have specific /23 addresses that are connected to each of these VNets. So what I can do here is, instead of listing each and every VNet prefix here, because this could be, I have 5 VNets here, but you could be having 50 VNets. Rather than doing all of the VNets, what I can do is I can list the 1020 prefix, but with a /16 subnet mask. So that means I'm covering all of the prefixes that are attached to this hub. So I can do that in my route map. I can say here, if the routes contain this address, go ahead and apply these different connections. So this is where we now look at what kind of actions we can perform. So here you can see that we have the ability to either modify the configuration. So I can say, I want to apply an ACE path change to this. So I can either append the ACE path if I want to do like a ACE path prepend, or I can say I want this ACE path to be replaced. I want a different ACE path added. Or I can say I want to do a route prefix. So instead of sending each and every prefix, what I can say is I can mention here to do a complete replace. So I don't send those 5 addresses. Instead of the 5 addresses, from here, what I will do is I will be sending a single prefix to my on-premises environment. So once I do that, I can then go ahead and apply these configurations to a connection. And based on that, then the configuration will get applied. I can also completely say drop these routes because I don't want these routes to be advertised to on-premises or to the connection that I'm applying to. So this is the way how you create it. So I'll just exit here, cancel, don't want to create one now. So once the configuration is done, you then go to this section where you go and apply a route map to a connection. And this is where you are going to either decide whether it's going to be applied to the inbound advertisements or whether it's going to be applied to the outbound advertisements. So if you look at what I did before, I applied my VNet route summary to an outbound address, outbound connection. So here what I have done is I've selected the express route connection type. So you can see here EXR, that is for express route. And I've selected express route and I said, for things that are going outbound to the express route, I want these routes to be summarized. So I don't want the individual routes to be advertised back to on premises. So that is the way how route maps are applied. I'll show the config on this one that I just applied. So if I click edit, it'll show me the summary map that I created. And you can see here, I've selected to terminate. So it's not going to process any further rules. It's got the summary range. So we are capturing every single VNet with this particular address range. And then I'm saying, don't advertise each and every prefix. Instead, just send the summary to my on-premises. So from an on-premises side of things, I'm only getting one route coming via my spoke VNets rather than having to advertise 50 prefixes back to my on-premises router. Once that's done, once you've applied, you also have this dashboard where you can also go and look at what are the routes that are being advertised. So you can see what are the inbound routes for a VNet, what are the outbound routes for a VNet. So you can really go and view what's happening in your environment. So it gives you good visibility to understand what are the different sources that are injecting routes to my environment, and also what are the different sources adding routes back to my other environments. So the environment, the configuration is applied. So what we'll do now is, if I go back to my Megaport setup, the expected behavior now is I should not be seeing these individual routes. Instead, I should see a single summary route. So I'm just going to hit reload. So that should hopefully drop the VNet routes and then send this single route back to my on-premises router. So yeah, that worked as expected. So you can see here there is a single route that is now advertised instead of individual routes coming in. So which means that I have a cleaner route table rather than having all these different VNets coming back to on-premises. I now only have a single route coming in. So that's a very quick demonstration on how route maps works, and route maps is still in preview, so it's not available as a general GA service. So that is a capability you can try out in preview. It's in public preview, so it doesn't need any whitelisting. You can go through our public documentation to have a look at how you can utilize route maps. So with that, what I will do is I will summarize what Deepak covered and also give a quick summary on Virtual WAN. So as we mentioned at the start, Virtual WAN is our network as a service offering, has multiple connectivity options for connecting branches, connecting VPN, and also connecting things like express routes, also adding capabilities to do point-to-site VPN connectivity. We've also extended this by adding security capability. So we have Azure Firewall as a first-party offering within Virtual WAN. And Firewall now supports inter-hub and inter-region connectivity without any limitations. And you can now also, as I demonstrated, utilize secured hub with routing intent together with express route encryption as well. We also have managed NVA capability. We've been onboarding a lot of partners for this service. So you will see each month we've added a number of new partners. We've recently added Checkpoint, Fortinet, and also we've added Palo Alto as well, which is essentially offering the NVS as a managed offering. So these NVS don't need to be managed by customers. For the Palo Alto offering, the NICs are inserted to the Virtual WAN environment, And then customers, again, don't need to go manage the environment. They can manage all of the configuration they want to do within the Palo Alto Prisma management platform. Again, this is very similar to the other partners as well. So we have partner offerings on top of Virtual WAN without customers needing to manage the environment. We also have a number of SD-WAN partners and also CPE devices on premises that would allow IPsec establishment towards a VPN gateway and allowing you to establish branch connectivity to a virtual WAN hub. We also have our security partners as well, Checkpoint, IBUS, and Zscaler. That will also give you the ability to secure internet outbound traffic. So if you have traffic from a VNet going out to the internet, you want to secure that through one of our internet security partners. You could also do that utilizing virtual WAN, again, without needing to run your own appliances or your own VMs in a VNet environment, rather utilize managed offerings. So with that, also want to cover some of the resources. So I mentioned a number of previews, mentioned a number of things that are in the documents. So feel free to you have a look at aka.ms vWAN docs. So this includes the documentation I mentioned. We also have a YouTube channel maintained by the Virtual WAN team, that is aks.ms vWAN videos. So if you go to that, you will also see some of the latest announcements like route maps available in the YouTube channel. So with that, I am going to conclude the session. So thank you all for your time. Hopefully this was useful. So we covered some of the new capabilities that was added. Routing intent, again, was a feature that was asked by many customers because it enables security not just within a region, but you can extend your security footprint across regions as well, especially for customers who are leveraging multi-region environments. And also I touched on how you can utilize encryption. We talked about new things that are happening inside point-to-site gateways, and also talked about some of the future investments around routing intent. Thank you all.
Thank you so much, Namal. Thank you so much, Deepak. And thank you all for those joining. We will have the session available on demand. So I'll post that in the Reactor Sydney meetup, or you can find it on our Microsoft Reactor YouTube channel. Thank you for joining, and we'll see you all next time. Bye for now.